Hi, my name is Gaspar Epro, and today I'm going to speak about adaptations in triceps surae muscle tendon unit mechanical properties in elite jumpers. From previous studies, we know that there are distinct differences between muscle and tendon and in their acute and long-term adaptive responses to mechanical loading, and this can lead to non-uniform biomechanical properties within the MTU. This means when muscle strength increases and it's not accompanied by increases in tendon stiffness or it declines, then the muscle can become too strong for the tendon, meaning that the tendon demand and the injury risk can increase. From previous studies in adolescent athletes, we know that the uniformity of muscle tendon adaptation can be affected by athletic training. However, it is currently unknown whether elite athletes demonstrate training-induced discordance within the MTU in different time periods after a season. Elite track and field jumpers are normally experiencing high Achilles tendon loading during training and competition, and are therefore predisposed to a greater risk for tendon injuries. The adaptation between muscle and tendon can be described by a simple scale model, where one side we have the muscle adaptation and the other side we have the tendon adaptation. When we look at relative changes in muscle strength and tendon stiffness in controlled subjects who are non-athletes, then it seems to be quite synchronous. Whereas in athletes, there seems to be quite high fluctuations in muscle strength and tendon stiffness over a time period, which makes this model or this scale unbalanced. Therefore, the aim of this study was to monitor triceps surae MTU adaptive changes in elite jumpers over several years of athletic training and the competition in order to detect potential non-uniform muscle and tendon adaptation due to habitual loading. Therefore, we analyzed 67 adult elite jumpers from the German national athletics team by using a mobile tendon muscle device, analysis device, by measuring the athletes approximately once a month over 1 year or full season. We performed the measurements at 9 different training centers all around Germany. When we look at the cross-sectional investigation, what we found out at the baseline, we saw that the elite athletes or the jumpers, that the takeoff leg has abnormally a higher muscle strength in the triceps surae and also a higher tendon stiffness, which were quite similar. We didn't find any differences in the maximal tendon strain. When we looked at the interlimb symmetry or symmetry indexes between muscle strength and tendon stiffness, then we didn't see any differences between those two parameters. And this was irrespective from the jumping discipline and gender. This means that the different habituomechanical loading profiles can lead to interlimb differences, but do not necessarily cause non-uniform adaptation within the triceps surae MTU and elite jumpers. However, when we look at individual values and the interlimb, the symmetry indexes, here I plotted the relationship between the symmetry index of triceps surae strength and the symmetry index of Achilles tendon stiffness. The positive values here show that the values were higher for the takeoff limb and vice versa when it's negative for the swing leg. When we now plot here a ideal line of an uniform MTU adaptation and the area around it, then we see that some athletes are not really exactly close to this line. Meaning, for instance, this subject here, when we see that they have approximately 25% higher muscle strength in the swing leg and a higher tendon stiffness or 10% for the takeoff leg, that means that the tendon demand for the swing leg is relatively higher because the tendon stiffness is lower and it doesn't match the tendon muscle strength. Therefore, we can say that the individual athletes may still show indices for non-uniform MTU adaptation, which can maybe not be found in the cross-sectional investigation. And this leads us to our longitudinal investigation over 1 year. We were able to analyze 18 athletes out of those 67 athletes from the cross-sectional study. We analyzed them once a month and over a 1 year period. Firstly, we analyzed the individual residuals of each athlete to measure the fluctuations in muscle and tendon adaptive changes over time. Furthermore, we analyzed the uniformity of those adaptive changes between muscle strength and tendon stiffness by using a cosine similarity of those relative changes between each session. What did we find out? We saw that when we look at the residuals of triceps sural muscle strength, tendon stiffness, and Achilles tendon maximal strain, then we saw that the takeoff leg has significantly greater fluctuations in the muscle strength and tendencies in stiffness and maximal Achilles tendon strain in comparison to the control group. When we look at the cosine similarities, then once again in takeoff leg, we saw lower similarities in the adaptive changes between muscle and tendon, meaning that the increase in muscle strength were not directly accompanied by the similar increases in tendon stiffness. However, the significance was relatively on the line, so the p-value was 0.046. So we decided to divide those subjects or athletes into two groups based on the cosine similarity in the takeoff leg. We then had two separate groups, low cosine similarity athletes and high cosine similarity athletes. And high cosine similarity athletes were quite similar to the control group, whereas cosine similarity in low group showed significantly lower values. And this was also reflected in the residuals. So the low cosine similarity group showed relatively greater fluctuations in the muscle strength, tendon stiffness, and more importantly, in the maximal tendon strain. Furthermore, we were able to analyze also two athletes with an Achilles tendinopathy, a chronic Achilles tendinopathy. And it was exactly the same. When we look at the affected leg and the healthy leg, then we saw higher fluctuations in the affected leg in plantar flexion moment, Achilles tendon stiffness, and maximal Achilles tendon strain. And similarly, we found also a lower cosine similarity in both of those subjects. So low and even completely negative cosine similarity in the athlete 2 here, meaning that the tendon adaptation and the muscle adaptation were completely in other directions. Now, we know that athletes have different phases in their year and the loading may vary. And we have preparation period and competition period. Here you can see one of the high jumpers who we were able to measure over 4 years. And I separated triceps sural muscle strength or maximal ankle moment and Achilles tendon stiffness into different phases based on the preparation and the competition period. We were able to analyze six subjects or six athletes over 4 years. And I analyzed if there are any differences between preparation and competition period. We didn't find any significant differences in the fluctuations of muscle strength and tendon stiffness in those 6 subjects, which doesn't mean that some individuals may still show some differences. So further investigations are needed. What did we find out? We found that elite jumpers, that the mechanical loading during training and competition leads to interlimb differences in triceps sural muscle strength and tendon stiffness, but it doesn't necessarily lead to interlimb asymmetries. The longitudinal investigation showed that the takeoff leg seems to have greater fluctuations in muscle strength and tendon stiffness and strain over one athletic season. However, over this 4-year longitudinal investigation, we were not able to identify differences in the MT uniformity between the preparation and competition period. Therefore, we can say that the repetitive plyometric and habitual mechanical loading during training and competition may affect the uniformity within the MTU and elite jumpers, leading to a temporarily increased demand on the tendon and potentially higher injury risk in the athletes. Thank you.